Hi, welcome back. Let's now talk about finding the area that's between two polar curves. So remember, when we're talking about between and we're talking about polar curves, we're talking about the curves being defined relative to the center, the origin here. So being between two curves, we are drawing pictures in which this area between the two curves is best defined being outside, where outside is defined as being further away from the origin, and inside is determined by being closer to the origin. All right, so when we're setting this up, again, we'll need to solve some polar equations, some equations involving trigonometric functions, to figure out where do we start slicing, where do we stop slicing, what is this initial theta value, what's this terminal theta value. And that's what we're going to, that's just a natural type of thing that occurs in this type of problem. So let's do an example. Calculate the area inside the curve r equals 3 sine of theta, and outside the curve r is equal to sine of theta plus 1. All right, so whenever you're faced with a problem like this, or really any type of question that involves like an area question, or definitely some sort of polar area question, it's always such an important thing to draw a picture. Understand which curve is which, and determine where the curves intersect. All right, so let's go back over to Mathematica. So we are going to use a polar plot again. Polar plot of two functions. 3 sine of theta and sine of theta plus 1. Where theta goes, again, let's do from 0 to 2 pi. All right, so one of these is 3 sine of theta, and one of them is sine of theta plus 1. So there's one of these that we've definitely run into before, and you should have some inkling of. So 3 sine of theta is of the form a or 2b sine theta, which means that it's a circle centered at 3 divided by 2, or at 0, 1.5. So that's our circle. And then this other one, this is called a cardioid. It is sine of theta plus 1. So here's our two equations, and what we'd like to do is we'd like to figure out what is the area that is inside r equals 3 sine theta, and outside r is equal to sine of theta plus 1. So that's this region right here. It's really important to understand what exactly you're calculating, because it could have been that you needed to be inside both curves, or that you were inside this orange curve and outside the circle. Figuring out exactly what the region is an important part of this process. All right, so let's go back to our picture. So what did we have? We had a circle, and we had this cardioid, and we're trying to figure out what the area is inside here. So we know that this outer function was r is equal to 3 sine of theta, and the inner function is r equals sine of theta plus 1. And so the next thing to do is figure out, well, where do these curves intersect? All right, and so where they intersect is solving an equation. So let's solve. Where is 3 sine of theta equal to sine of theta plus 1? Well, let's bring one of the signs over to the other side. 2 sine of theta is equal to 1. So that means that sine of theta is equal to 1/2. All right, so where is sine of theta equal to 1/2? Well, it occurs on the way up of this, so this is going to be a pi over 6, and on the way down, so that's going to be 5 pi over 6. So what we're going to be doing is we're going to be chopping. So we have our two different angles. This is theta is equal to pi over 6, and this is theta is equal to 5 pi over 6. And what we're doing is we're doing these slices as we go out. And so what we need to do is we need to take the area inside the outer curve and subtract off the area outside the inner curve. And what we have to remember is that our formula for area is involving the function squared divided by 2. So calculate area by integral for theta goes from pi over 6 to theta goes to 5 pi over 6 of 1/2 outer function squared. Outer function was the 3 sine of theta. And subtract off 1/2 inner function squared, sine of theta plus 1 squared d theta. Right, so remember here we're using that area is equal to the integral of 1/2 function squared d theta. All right, and again, let's use Mathematica to solve this. All right, so let's calculate the integrate. We have 1/2 times 3 sine of theta squared minus 1/2 of sine of theta plus 1 squared, where theta goes from pi over 6 to 5 pi over 6. The answer is pi. So this area, so this integral evaluates to pi. If you're doing this integral by hand, it's really important to, if we were to expand this, what would we get? We would get 1/2 integral of, from pi over 6 to 5 pi over 6 of 9 sine squared theta minus sine squared theta minus 2 sine theta minus 1 d theta. So this gives us 1/2 integral from pi over 6 to 5 pi over 6 of 8 sine squared theta minus 2 sine theta minus 1 d theta. And if you're ever doing an integral with a sine squared or a cosine squared, then it's important to remember for first that sine squared theta is equal to 1 minus cosine of 2 theta divided by 2, whereas cosine squared theta is equal to 1 plus cosine of 2 theta over 2. So the reason why that's going to be helpful here is we would get 1/2 integral from pi over 6 to 5 pi over 6 of this goes in here. We get 4 times 1 minus cosine of 2 theta minus 2 sine of theta minus 1. And now it's easy to integrate cosine of 2 theta, much easier than it is to integrate sine squared of theta. All right, I will see you again. Ciao.